Hey everyone, I'm Monica, and I want to walk you through federating two different data sources using Starburst Galaxy. We're going to be federating S3 and MongoDB, and then we're also going to build out a data lake reporting structure within S3, also using Starburst Galaxy. I have all of the instructions for how to complete this within the GitHub repository, so go ahead and check that out, and let's get started. So the premise of this example is that we have Pokemon Go data being ingested into S3. Essentially, this has the geolocation data of the Pokemon spawns as well as the encounter information, when it disappeared, etc. But what it doesn't have is any of the Pokemon's abilities, the type, any sort of, even the name. That's all contained in the Pokédex, which is stored in MongoDB. And for this purpose, I've coined Pokemon GoDB. Essentially, to make any sort of meaningful information out of the data that we have to combine the two together, the geolocation data with the Pokédex data located in MongoDB. To do this, we're going to build out a reporting structure in our data lake using Starburst Galaxy. First, we're going to use Starburst Galaxy to read the data that's in the LAN layer. We're then going to build out the structure layer and clean and optimize that data into, more structured tables, better file formats, etc. Finally, in the consume layer, what we're going to do is we're going to combine the two structure layer tables together into one queryable table that's ready to be consumed by any sort of data consumer out there. We're then going to throw that final table into ThoughtSpot and do some visualizations and analysis to see what Pokemon is most common around the San Francisco Bay. Okay, so the data stored in MongoDB looks like this. It's in CSV format and it's a static table. You can see the number, name, type, ability information. Here's how it looks. Now let's jump over into the CSV that's being ingested into S3. This is what it looks like. Pretty bare bones, has basically identification information, geolocation data, and encounter information. So before getting started, I just wanted to show you the live board that I've created in ThoughtSpot. This is based off of the connection to Starburst Galaxy, and once I create the final table, it should load. So we'll see if that works. Okay, jumping into Starburst Galaxy, the first thing I want to do is create my catalogs. I'm going to first create the catalog connecting to S3. So I'm just going to go through, provide a cute little name, connect with that access key, get that information over. And I'm also going to connect with glue and put my default bucket and directory. Also want to select the default table format as iceberg. Okay, so my S3 catalog is created. I'm going to go back and I want to create my MongoDB catalog as well. So I have my catalog name. Let's name it Pokemon Go. And then I want to add the connection information. And I'm going to remove that. Autofill is my worst enemy. And we are ready to go. So connect that catalog. Next, I want to create my cluster. Let's name it something cute. And then I want to combine to both of those catalogs that we just created. And then I want to select a region. We're not doing anything crazy, so I'm going to leave execution mode off, and let's create our cluster. So that will kick up, and then we will go back to the query editor once it's up and running. Okay, my cluster is up and running, and I've given the account admin role the necessary permissions to insert and create tables, so we're ready to get going. First, I want to make sure I've selected the cluster and the S3 catalog so that we can build out our reporting structure. I want to build my LAN layer in Hive just to kind of make another difference between, the LAN layer and the structure and the consume layer. So I'm going to run that first. I'm going to run the schema, creating that LAN layer. And then what I want to do is create the table from my external location where the CSV data is being ingested. This is pulling the geolocation data for the Pokemon spawns. So that's all ready to go. Let's run it. Here you can see all of the same information from that CSV we looked at previously. Moving on to the structure layer, first thing I want to do is create my schema for holding all of my iceberg tables. The next thing I want to do is create the Pokédex structure table from MongoDB in iceberg format. You can see that we're making it into an org file and that we are casting all of the values as the correct data types. And if you go down here, you can see we are pulling from the MongoDB catalog. So let's run that table. There you have it. And the next thing we want to do is validate that table. Yep, looks good to us. We have all of the ability information. Looks good to go. We're going to create our second structure table, which is going to be based off of that incoming Pokemon spawn geolocation data that we've created. The land layer, and now we're creating the structure layer where we are casting all of the data types as the correct format and also creating an org file. Running that table. Perfect. Let's select from there, see what we have. Looks good. So finally, we're going to create our consume table. We're going to pull all of the information from the Pokemon spawns and then add in some of the information from the Pokédex. And we're only going to be pulling Pokemon that are in the Bay Area. So I'm going to create that table now. And let's select from it. We're going to see some examples. There you go. You have the number, the name, the latitude, longitude, encounter information, as well as the type and the legendary status. So just showing a little bit more of the different roles and privileges you can assign using Starburst Galaxy, I want to show that here in our account admin role, we can update the table. This will come back null. This will come back with 0. That was supposed to happen, but it's just showing that we have the ability in this account admin role to update the table. We also have the ability to select. What I want to do now is show you the consume layer access role that I've created specifically for data consumers. And we can see that we can indeed select from the table. However, we won't be able to update and we'll get an access denied. So just something to keep in mind as you integrate with Starburst Galaxy, all of the cool role-based access control things you can do. So let's pop back over to ThoughtSpot and now refresh, and we should be able to see loaded data. Okay, here we are. We can see the Pokemon prevalence by name. If we scroll down, you can see the geolocation data. So we have confined it to the Bay Area of San Francisco. And here you can see which spots are most frequently spawned. If we go check out Alcatraz, you can see that is a pretty hot spot for Pokemon to be. So something to know if you're ever visiting. And we can also see the types of Pokemon. So it makes sense because we're in the bay and I've included the water in the geolocation. That water is the highest type of Pokemon. And we can also break that down further and look at the type 1 and the type 2. So you can see, interesting that there's a lot of flying Pokemon in our specific region. So I want to pop back into Starburst Galaxy and just show you something really cool with the query history. We can see here's the update query that failed, and then from here you can see all of the queries that ThoughtSpot ran to create that live board. So definitely something cool. Thanks for joining me today. If you have any questions and you're going through the GitHub repository, feel free to reach out. I'd love to help.